Hello dear students, I welcome you all to this class. In the previous classes, we did talk about different types of forces and all. So in this class, we'll start from magnetic force. So you must have known what a magnet is. You have often seen a magnet. It attracts iron nails, pins, keys and other objects made of iron like steel, nickel and cobalt. So magnet generally attracts objects which is made up of iron, nickel, cobalt, steel and all that. Okay, everybody knows. So this is an iron. Here you can see a nail which may be iron nail. So magnet attracts iron towards itself. A magnet also attracts or repel another magnet. If you have two magnet, if you have a magnet and an iron nail, so this magnet is always going to attract iron nail towards itself. Okay. Now, if you have two different magnets, suppose this is one magnet, this is another magnet. Now, these two magnets may attract each other or repel each other. So, in any magnet there are two poles, north pole and south pole. Suppose this is north pole, this is south pole, this is north pole, this is south pole. Here this is the south pole of this magnet, this is the north pole of this magnet. Now this opposite pole, they attract each other, they will attract each other. Now on the other hand, if you bring two magnet, suppose this is north pole, this is south pole of the magnet, this is another magnet, this is south pole and this is north pole. So in this case, the two magnets are facing the same pole of the two magnets are facing each other, south and south. So they will repel each other. They will try to push each other. So whether south or north face each other like this, north, north. If the same pole face each other, they try to push each other. If the opposite pole face each other, they try to pull each other. Okay. So this force associated with magnet are called magnetic force. Now remember one thing, if we have taken two magnets, then only they will attract and repel each other depending upon the position of their pole. Now, if you take one magnet and another one, maybe iron nail or steel or nickel or cobalt, they will attract each other. Okay. So you can see magnetic force act from a distance. So all know that. Suppose this is a magnet. If you bring a piece of iron, it is going to attract it. Okay, it acts from a distance. It is a non-contact force. Therefore, it is a non-contact force. Magnets cause a force in the area around them. The area of force around a magnet is called magnetic field. Okay. Now see this. Suppose this is a magnet. This one. Now within this region, within this area, if you bring certain object, suppose a piece of iron, then it is going to be attracted by magnet. Okay, that is the region. So this area, this region in which if you bring a piece of magnet, then it is going to be attracted, that region is called magnetic field. Okay. So what is magnetic field? Let us try to understand. So magnetic field is nothing but an area. Suppose this is a magnet. Suppose this is a magnet. So within this region, if you bring a piece of iron or piece of nail or a nail, so it is going to be attracted by the magnet. If you bring the same piece of nail and keep it over here, then this piece of nail is not going to be attracted by the magnet. So this area or this region within which the magnet attracts the piece of nail, this region or this area is called magnetic field. Okay. So we cannot see a magnetic field, but we can see what it does. The magnetic field, it is invisible, you cannot see it, but within the magnetic field, if you bring a piece of nail, then it's going to be attracted by the iron. So that one we can see or we can feel. So this is the picture of a magnetic compass. You can see it shows direction. You might have seen the famous movie The Pirates of the Caribbean, where Captain Jack Sparrow always having this compass that point towards the destination or the destiny of that person. Okay, if you have watched that movie. So the Earth also has a magnetic field. It is surrounded by magnetic lines of forces. We can use magnetic compass to see magnetic field of Earth. So here there is one term. It is known as magnetic lines of forces. What is the meaning of this? So suppose if I draw a diagram of a magnet. Now this magnet is known as bar magnet. Okay, you'll study about this one in higher classes about bar magnet, solenoid and toroid and all those things. So suppose this is a bar magnet. Now how the magnetic fields are arranged? Magnetic fields are arranged like this. Okay, like one line after another line, like this they are arranged. Okay, like this they are arranged. Now these lines are known as magnetic lines of forces. These lines. So this is the magnetic field. Within the magnetic field is arranged like this. One line, then another line, then another line. So these lines are known as magnetic lines of forces. Okay. Next term is nuclear force. Nuclear forces act among the small particles in the central part of an atom, which is called nucleus. So you know that any atom is having two parts. One is nuclear part, where neutron and proton is present. Another one is non-nuclear part, where electron revolves. Okay. So nuclear force act among the small particles in the central part of an atom. Central part of an atom is this region, which is having neutron and proton. Hmm. So the central part of an atom, that is nucleus, attracts nucleus of another atom. Okay, so this force of attraction is known as nuclear force. They are very strong non-contact force. So this force of attraction are very strong. They are non-contact in nature, which held the particle together. Okay, so nuclear force means the different atoms attract each other. Okay, which holds the atom together. Now here this in this diagram you can see these magnetic lines of forces. These are the lines. Okay, here you can see. Okay, these are the lines of forces. Here, these are arranged in the form of dots, dot like that. Okay. Next one is spring balance. In the previous class, I told you something about spring balance and beam balance. Beam balance is used to measure mass of the body. Spring balance is used to measure weight of the body. Okay. So spring balance is a device which is used to measure the weight of a body. Okay. So here this is a spring balance. Spring balance is nothing but a spring having a scale. This is a spring. This is a scale. Now when you put some weight over here, okay, some object over here, the spring moves down. This is the indicator. When this object pulls the spring in the downward direction. Now, as the spring moves in the downward direction, the indicator also moves in the downward direction. So here the pointer shows the mark 5, 10, 15, 20, 25, 30 like that. Suppose it shows this mark 10. So weight of the body will be 10 Newton. Suppose it shows 30. Then weight of the body will be 30 Newton like that. The object to be weighted is attached to the hook of spring balance, which is held vertically either from a hook with or with a hand. Now here it is held vertically. Here the spring balance is. Now this is the hook of the spring balance. You are going to put you are going to hang the object here whose weight you want to measure. The spring gets raised due to the gravitational pull, and hence the pointer slides down on the engraved scale. So here this object is going to pull the spring in the downward direction. As the spring moves in the downward direction, this pointer will also move. Now it will show the exact value. The weight of the object is read from the position of the pointer on the scale. So with respect to the position of the pointer, its weight is measured. As I told you, if it shows 10, then this 10 Newton, 30, then 30 Newton, 40, that 40 Newton, like that. Okay. So, wow, this is all about this chapter. Now we have finished this chapter. Now let us do some question answer, the exercise. So the first question, I will tell you some of the answer of this question. Pick the right or the correct option. Pushing a rock from a hilltop is an example of, if you push a rock from a hilltop, it is an example of what? Whether it is a magnetic force, you are pushing something, obviously it cannot be magnetic force. Frictional force, no. Frictional force opposes the motion of the body. Electrostatic force, no. Electrostatic force are related to atoms, electrons. Muscular force, yes, this is the answer. Because you are using your muscle to pull this. So muscular force is the answer. Second question, a stone thrown with a catapult falls back on the ground, because if we throw a stone, it always falls on the ground. What is the reason? Okay, so first option, the muscles apply force. No, the muscles apply force on the stone so that the stone will move in the upward direction, not in the downward direction. The stone applies force where the stone is going to apply force. No, the earth exerts force. Earth exerts force. Why does it move? Yes, Earth pulls it in the downward direction, which is known as gravity, gravity of the Earth. Okay, so this is the right answer. The SI unit of force. SI unit of force is Newton. C. Which of the following force is only attractive? Only attractive. Okay, magnetic force, no. We saw that this is attractive as well as repulsive. Electrostatic force, no. Gravitational force. It is always attractive in nature. 5. Under which condition can a moving object change its direction? Okay. So, by reducing friction, no, reducing friction increases the speed of the body. By increasing friction, no, it decreases the speed of the body. And not applying force, if you will not apply force, nothing is going to happen by applying force. This is the answer. A man walking on the street slips on a banana skin because if someone is walking, he slips. Why? Because it is sticky. All that points there is very little friction. Yes, due to the little friction, his foot crossed it. So here the answer would be, at that point there is a very little friction between his shoes and the ground. Due to this little friction, this person slips. Yes, the friction reduces. Okay. Next one. Dash is a non-contact force. Which one is a non-contact force? Muscular force, this is contact. Frictional force, contact. Elastic force, contact. Gravitational force, this is the answer. Now B. True or false? Force always has a particular direction. Yes, this is true. Friction is always harmful. No. Sometimes it may be harmful, sometimes it is harmless. Then again, true, false. A magnet attracts all metal towards itself. No, it does not attract all metals. Some of the metals are getting attracted by magnet. For example, iron. You cannot attract wood, or you cannot attract gold. Gold is not getting attracted by magnet. So force can increase or decrease the speed of the moving object. Yes, if you apply force in the direction of motion of the body, its speed is going to be increased. Otherwise, in the opposite direction, it is going to be decreased. Now, yes, no type. Power applied to a carom board reduces friction. Okay. If you apply powder, it reduces friction. Yes. Force is energy. No. Force or energy are related to each other, but they are not exactly equal. They are different things. Gravity is a contact force. No. Then analogy type. Contact force, lifting a bucket of water. Non-contact force, you can give any example. Like lifting a bucket of water is example of contact force. And then what is the example of non-contact force? You can give any one example. For example, falling of apple from apple tree, or any other example that comes in your mind. Next. Yeah, let me write the answers. How many questions? See, there are 11 questions and there are 10 boxes. So we'll make another box, box number 11. Okay. So, at 1, pulling a drawer, pulling a drawer out from a table. Okay. So, this one would be contact force. You are pulling something. So, you are making contact. Without contact, you cannot pull it. Now, force. Okay. What is force? Push or pull. This one. Force is a pull. Better I should write it here. First one is I. Second one is H. Third, moving ball stops after some time due to. Moving ball stops after some time. Why? What is the reason? Because of friction. K. Then 4. Spring balance. Spring balance measure weight. So where weight is written? Weight of the body. Here. So A. Then 5. An apple falls on the earth due to. What is the reason? Why does an apple fall on the earth? Gravitational force. B. Then 6. The leather shoes of new shoes are rubbed on a rough surface. What is the reason? Friction produces heat. This one G. 7. Magnet attracts iron filings. Non-contact force. Magnetic force, it attracting iron, it is a non-contact force. Then 8. A piece of chalk wears out as it is used on a blackboard. What is the reason? Friction causes wear and tear. C. Then 9. Force requires to lift 100 gram mass vertically against the gravity. So what is 9? 9 is F kilogram weight, F, then 10. Force is measured in Newton, D. Now which one is remaining? You see which one remains here? J, electrostatic force. Tiny bits of dry paper are pulled by rubber gum. That is J, electrostatic force. J. Okay. So far we have completed this much. Now rest of the questions we will discuss in the next class. Then this chapter will be completed. Okay. So this is all about today's class. Thank you and have a nice day.